It's a revelation that has been decades in the making. Scientists have finally cracked the long-standing enigma surrounding the Silverpit Crater, a hidden geological feature located in the North Sea. After 20 years of intense debate and investigation, researchers now present compelling evidence that this crater was formed by an asteroid impact over 40 million years ago. The Silverpit Crater, which was first identified in 2002, approximately 80 miles, 129 kilometers off the coast of Yorkshire, measures an impressive 1.8 miles, 3 kilometers in diameter, and is situated about 766 yards, 700 meters beneath the ocean floor. Its distinct circular shape and the presence of a central peak are typical indicators of a cosmic collision. However, due to the lack of conclusive proof, various alternative theories emerged, suggesting that the crater might have been caused by shifting salt deposits underground or ancient volcanic activity. Now, a research team led by Ustein Nicholson from Heriot-Watt University in Scotland has finally put the debate to rest. By employing advanced 3D seismic imaging techniques alongside drill samples from an oil well drilled in the 1980s, the researchers have constructed the most detailed representation of the crater to date, confirming its origin as a result of an asteroid impact. Nicholson expressed the significance of their findings, stating, "Silverpit is a rare and exceptionally preserved hypervelocity impact crater. We can utilize these discoveries to gain insights into how asteroid impacts have influenced our planet's history and to anticipate potential outcomes should we face an asteroid collision in the future." The newly acquired seismic data has provided an unprecedented view of the crater's structure, revealing clear signs of impact, such as a central uplift, a surrounding moat, fractured rock zones, and even smaller secondary craters formed by debris that fell back to Earth. The arrangement of faults surrounding the crater indicates that the asteroid struck from the west at a shallow angle, with rocks being pulled apart on the western side and compressed on the eastern side. The key evidence came from microscopic examinations of drill samples, which revealed rare grains of quartz and feldspar marked with tiny scars. These scars are indicative of the extreme pressures generated during a hypervelocity impact, something that cannot be replicated by any geological processes on Earth. We were incredibly fortunate to discover these. It was like finding a needle in a haystack, Nicholson remarked. These findings unequivocally support the impact crater theory, as they exhibit a structure that can only be formed under extreme shock pressures. According to computer simulations based on the evidence, the asteroid that created the Silverpit Crater was approximately 175 yards, 160 meters wide, about the length of 1.5 football fields, and was traveling at a staggering speed of over 9 miles per second, 15 kilometers per second. The impact would have generated a plume of rock and seawater that soared to a height of 1 mile, 1.5 kilometers, before collapsing back into the ocean, creating a tsunami that reached heights of over 109 yards, 100 meters. The seismic data also indicates that this cataclysmic event occurred during the Middle Eocene epoch, specifically between 43 million and 46 million years ago. The debate regarding the crater's origins reached a pivotal moment in 2009 during a Geological Society meeting in London, where a significant majority of geologists present voted in favor of a non-impact origin for the structure. For many, that seemed to be the final verdict. Nicholson reflected in a separate post on Springer Nature's Behind the Paper, where researchers share the background of their study. "I must admit that I had also been swayed by the prevailing belief that the structure had a more ordinary explanation, and that the evidence was against the impact theory." 2 decades after the initial discovery of Silverpit, Nicholson and his team revisited the contentious issue almost serendipitously. In 2022, following their discovery of the Nadir crater off the coast of West Africa, They received a suggestion from a colleague at the North Sea Transition Authority to re-examine Silverpit. This prompted them to delve into old seismic records, new high-resolution survey data, drill cuttings, and impact simulations, ultimately leading to a convergence of evidence supporting the idea that Silverpit was indeed formed by a violent asteroid impact rather than mundane geological processes. I always believed that the impact hypothesis was the simplest and most consistent explanation for the observations, stated Gareth Collins, a co-author of the study and a professor of planetary science at Imperial College London. It is incredibly gratifying to have finally found the definitive proof. The unique preservation of the crater, which includes a flat-topped, pitted central uplift that may record intense chemical. With this confirmation, Silverpit now stands alongside the famous Chicxulub crater in Mexico, which is associated with the extinction of the dinosaurs, and the recently discovered Nadir crater off West Africa. Nicholson emphasized the importance of this exceptionally preserved structure, stating, "It can continue to provide crucial insights into what transpired during this specific event, as well as what might occur if a similar event were to happen in the future." This groundbreaking research is detailed in a paper published on September 20th in the journal Nature Communications. Join our space forums to keep the conversation going about the latest missions, night sky observations, and more. If you have any news tips, corrections, or comments, feel free to reach out to us.